Bridge. A bridge is an structure built to span a physical obstacle for the purpose of providing passage through the obstacle. The main different designs of bridges diverge depending on the function of the bridge and the nature of the land where the bridge is constructed. There are three major types of bridge. The beam bridge. Beam bridges are horizontal beams supported at each end by piers. The weight of the bridge and any traffic on it is directly supported by the piers. The weight is traveling straight downward. The force of compression manifests itself on the top side of the beam bridge deck. This causes the upper proportion of the decks to shorten, and the result of this compression on the upper proportion of the deck causes tension in the lower proportion of the deck, and this tension causes the lower proportion of the beam to extend. The arch bridge is a semicircular structure with abutments on each end. The design of the arch, the semicircle, naturally differs the weight from the bridge deck to abutment. Arch bridges are always under compression. The force of compression is pushed out along the curve of the arch towards the abutment. The tension in an arch is insignificant. The shape of this arch itself is all that it needs to effectively dissipate the weight from the center of the deck to the abutment, as with the beam bridge. To limit of sight will eventually overtake the natural strength of the arch. The suspension bridge. A suspension bridge is one where cables are strung across the river, and the deck is suspended from these cables. Modern suspension bridges have two tall towers throughout which the cables are strung. Thus the towers are supporting the majority of the roadway's weight. The force of compression pushes down of the suspension bridge deck, but because it is a suspended roadway, the cables transfer the compression to the towers, which dissipates the compression directly into the ears where they are firmly entrenched. The supporting cables running between the two anchors are the lucky recipients of these tension forces. The cables are literally stretched from the weight of the bridge, and each traffic has the run from anchor to anchor. The anchors are also under tension, but since they, like the towers, are well firmly to the earth, the tension they experience is dissipated. The basic use of a bridge is solving the problem of crossing an obstacle in such a way as to cut down the effort and time needed to do so. This means that the supply of food and other goods can get across the obstacle in a shorter time, and it means that in economic terms the cost of travel and trade goes down. Other longer-term payoff for the easily travel, which is crucially dependent on good grades, come as a result of increased opportunity to share ideas, intellectual, political, and religious. Gateshead Millennium Bridge. Location: between Newcastle upon Tyne, Tyne and Ware, North East England, United Kingdom, and Gateshead, Tyne and Ware, North East England, United Kingdom. Purpose of the bridge: it is pedestrian and cyclist bridge. Type of bridge: it's a mixture of an arch bridge and a bascule bridge. Aesthetically, can be conceived as an arch bridge because of the semicircular form that hills the deck with cables, but functionally is a bascule bridge. A bascule bridge is a mobile bridge with a counterweight that continues balance the span all the way throughout the entire upper swing it providing clearance for both traffic. Bascule is a French term for Swiss unbalance, and bascule bridges operate along the same principle. They are the most common type of mobile bridge in existence because they open quickly and require relative light energy to operate. Designers conceived and designed by architects Wilkinson, Aaron, and structural engineers Whitford. Materials: the cables are made of stainless steel, and the arch is also made of steel. Dimensions: main span 105 meters, width 8 meters, total length 126 meters, height 15 meters, weight 815 tons, cost 22 millions of euros. Design: the bridge not only looks stunning but also uses precision engineering to detail, like the opening of a night. The bridge design breaks down into several elements: the supporting deck that forms an arch over the driver, the deck that contains the pedestrian walkway and cycle path, the dividing head, and the caissons which contain the hydraulic system. The pedestrian and cycle deck is an almost horizontal curve suspended above the driver from a series of suspension cables. These suspension cables go from the arch to deck, helping to give stability for those crossing the bridge. The pedestrian deck is about a foot higher than the cycleway to provide clear views of the driver and allow a higher safety bar to be used for cyclists. There are two glass canopies of each end of the bridge, which are used to operate the hydraulic system. Finally, in order to alert pedestrians and cyclists to the bridge opening and closing, recessing in ground units were custom designed. Green LEDs fit into a fiber optic shape of a go-around symbol. Red LEDs fit into a no-entry symbol. The bridge still is a single rigid structure. As the arch lowers, the pathway rises, each counterbalancing the others. This ensures a minimal amount of electricity is used during its tilt. Technology involved in its construction. Everyone is familiar with the concept of the bascule bridge, a structure that spills open in the middle, with both halves raised in order to allow which sheets to pass through. It's a standard engineering concept that has not changed much in decades. But the Gateshead is the world's first tap-in bridge. This elegant arched structure literally tips on its sides to make way for maritime traffic. The tipping movement of the two curves that make up the bridge structure is comparable to opening end of an A-light. The action is provided by 6 45 cm diameter hydraulic rims, dotted the bridge back on large bearings to allow slab shifts and boat to pass underneath. The bridge takes a little has 4.5 minutes to rotate through the full 40 grade from 2 for close to open depending on wind speed. Advantage and disadvantage of this bridge for the specific community. Some of the advantages of this bridge are the possibility to rotate every time a sheet has to go through. The bridge takes a little has 4.5 minutes to rotate. The is notably silent, is so energy efficient that it costs just 3.6 each time it opens.